the detection of fake web shops based on internet measurements and the analysis of the data that comes out of these measurements. My talk will be about technology transfer, and I'm sure you guys heard a lot about that. And it's basically about working together with academic institutions and other research labs to do research on how to further improve the security and stability of the internet infrastructure. And that's something that we do all day at SIDN Labs.
Welcome to talk.cyberscni.fr.
Bienvenue.
Welcome to the 25th edition. I will just put my sound a little bit less loud. Yeah, so welcome to already the 25th edition of the Talk CyberCNI speaker series, your monthly speaker series on different challenges and opportunities you have around the cybersecurity landscape. And today is the 25th edition already, which I'm very, very proud of. And we have a great speaker today. We have Cristian Hesselman, the director of SIDN Labs from the Netherlands. And before I tell you a little bit more about him and his talk about increasing internet security by bridging research and operations, let me give you, as usual, some info about the Slido. So, as always, we have a Slido as a second screen where you can ask your questions, you can see which questions were already asked, you can upvote them, you can download them, and I cordially invite you to open the second screen and follow the discussion, contribute to the discussion. As you know, the format will be about 45 minutes, up to an hour of presentation of Cristian about his topic. And then afterwards we'll have the remaining time until the full 90 minutes for the discussion of the questions. Typically we have about 30 questions, 30 to 40 questions, which easily fill the amount of time that remains. And as we typically have more questions than we can ask, really use the opportunity to upvote those questions that you are most interested in. You will see the link. I will show it a little bit during our session today, and you also see it in the text below the banner in the regular speaker setting. So, as you know, the goal of the speaker series is informing a larger public on interesting topics on cybersecurity. And Cristian has a super interesting topic because it's bridging between research and operations for internet security. And this is, of course, something that is super important because research is something that is typically ahead in the sense these are the things that will be deployed in some of the years. And institutions like the one Cristian is working for or leading, they are really helping doing that faster so that we have more security in shorter amounts of time. So, Cristian, he directs the SIDN Labs, and this is the research arm of the operator of the .nl top-level domain, SIDN, and his work focuses on advancing the security of the internet to support our digital society. He's also a part-time professor at the University of Twente, a researcher at the Twente University Center for Cybersecurity Research, Tucker, and he chairs the board of directors of NLnet Labs, which are all very interesting and cool positions that give him lots of information that will be we are super interested in hearing a little bit about. And his personal website is www.hesselman.net, where you can find even more information about him. And yeah, as said, we're already looking forward to Cristian's talk. And Cristian, the floor is yours for the next 45 to 60 minutes. We're eager to hear what cool things you have to share with us. And then afterwards we'll have a moderated discussion. Today we have Erkin Kierdan and Alexander Kabil as moderators for the discussion. Already a warm welcome also to them. And we'll see them in about a short hour. Okay, Cristian, then I hand over to you and look forward to your talk.
Cool. So thank you, Mark Oliver, for the kind introduction.
So, hey everyone, I'm Christian, and my talk will be about increasing internet security by bridging research and operations. And that's because my team, SIDN Labs, is basically doing all that, mostly all of it, as our core task, you could say. So I'll be talking about the core of the internet, which is basically the bottom half of the iceberg that you see on the left of my slide, and the iceberg represents the internet. And normal users, they typically see the top of the iceberg in terms of apps and user interfaces and websites and that sort of thing. But we particularly focus on the bottom half of the iceberg, which involves network operators and DNS operators and scrubbing centers and all that to make the top of the iceberg work for everyone on the planet. Okay. So I'd like to start my talk with these few pictures here, which are actually have been quite inspiring to me. The two pictures on the left, because back in 2017, I visited the birthplace of the internet, which is a room at UCLA, not that big actually, with all the equipment in there that was used to start up the internet back in 1969. So what you're seeing in the picture on the top left is Professor Len Kleinrock, who used to lead the DARPA effort, so the predecessor of the internet, and he's actually standing next to one of the routers of that time. So that's 1969, and as you can see, it's humongous compared to the routers that we currently have in our office. And the internet originally was designed to interconnect equipment like the ones that you see on the bottom left, which are in this case is a tape drive, because folk wanted to share this expensive equipment, or at least at that time expensive equipment, across the internet, and that's why they came up with the concept of internet working. Okay. So, and the picture at the map of the United States shows the initial map of the internet, also back in 1969, and the first connection was actually established between UCLA and Stanford, and that's the hardware that they used to make that connection is actually the stuff that you see on the left of the picture of the slide. Okay, and as we can see, the internet has grown a lot over the past 50 years. That's the picture at the bottom, which shows the number of autonomous systems that make up the internet. And well, there used to be around a few hundred back in the late 1990s, but right now it's roughly around 73,000 different autonomous systems, or networks, if you will. So the stuff that we focus on at SIDN Labs is basically internet security. And folks sometimes say, well, the internet was not really invented with security in mind. I think that's partially true, because the internet was focused on providing continuous communication despite loss of networks, right? So if there would be an incident in the network somewhere, there would be a partition, or there would be a break of a link, or a router would crash or something like that, then the rest of the network would be able to reroute traffic, and communications would continue as normal. And that's basically the A in CIA, so with CIA being confidentiality, integrity, and availability, which are the standard principles of security. And an interesting paper in that regard might be the paper that I'm showing on the right, which is the design philosophy of the DARPA Internet Protocols, which was published in 1988 and republished in 1995, where David Clark actually tried to summarize the design decisions for the internet back in the day. And the most important one was number one was internet communication must continue despite loss of networks or gateways. So that's really the availability of communications that's being expressed in that design goal. Okay, so that's why I think that the internet was, to some extent, developed with security in mind, although it only focused on availability and not really on confidentiality and integrity. So this is basically what we do at SIDN Labs. We try to further improve the internet, the security of the internet as we know it. Okay. Also, the paper, it might be quite interesting to read if you're interested, because it gives I think, a very nice perspective on how the internet was designed and why certain design decisions were made. Okay, so the goal for today's presentation is basically to show you a couple of examples or use cases on how we try to increase the security of the internet infrastructure by bridging research and operations. And I also hope to get some of your feedback on that work. That's also very interesting. And what I'd like to achieve today, and maybe you can let me know if I achieve that goal at the end, is to provide some inspiration for the technology transfer paragraphs that folk usually need to write for research proposals, right? So maybe this will provide you with some inspiration that you can use in future project proposals. All right. So I'm not sure to what extent you guys are aware of how the internet works. I'm just going to give a brief overview of that so that we're all roughly on the same page. So this is basically showing, this slide is showing how the internet works from a very high level perspective. So in the picture on the left, you're seeing a mobile device on the left, which is receiving content from a website, which is www.utwente.nl. And most people who use a mobile phone or a laptop or whatever, they just see the web pages that they get from the server, and they don't really see what's happening underneath. But underneath, the internet is actually a network of networks, hence the term internet. And that's what this picture shows. So in this particular image, the web pages are coming from the server, but in reality, it's a data stream that travels through, in this case, 4 different networks before it actually arrives at the client. So the traffic in this case goes through network 7, 6, 2, and 1. And these networks are each being operated by independent network operators. So in this case, in this example, it's Vodafone Libertel and Serve and a few others, right? So the characteristics of this infrastructure are that it's quite, no, it's very large at this point, right? So there's various degrees of complexity. So for example, there can be various routers per autonomous system or per network. So it can range from tens to maybe to thousands of routers per network. There are there are multiple connection points for each network. So each network at least has to have one, obviously, but some networks also have hundreds of network connection points, okay? There's engineers, so the people actually running the network. It can vary from a handful of network engineers to a few hundreds for large networks. And what's important in the internet is that there is no coordination, there is no central authority. Each autonomous system plans its resources and its network autonomously, and that's why it's called an autonomous system. So it's an expression of ownership, and there is no coordination between different autonomous systems, okay? And that has been one of the strengths of the internet and has enabled it to grow because there is no central authority that has to regulate everything. On the right, there is actually, so the picture on the left was perhaps the truth, 20 years ago. But today, the situation is slightly different because there are also these large networks, wide area networks being operated by companies such as Google and Facebook that span the entire globe. So if you look at the picture on the right, then at the bottom with the word standard, that's a picture of the standard internet model that we were used to. So that basically resembles the picture on the left, which means that if you were to go from a client to a server, so with the client in the yellow on the right and the server on the left in the blue, you would go through multiple networks. However, with these large wide area networks, there's now a what Jeff Houston calls the death of transit, which means that clients have much shorter paths to the server. So in this case, in this example, the user goes through their local network, which then connects to the Google network, which is global, which then connects to one of the services that Google provides. So the number of hops is being reduced to perhaps 2, maybe 3, rather than the 4, 5, 6, or 7 that you would usually get on the internet, old school, so to speak. So what we can see here is that these wide area networks are playing an increasing role in the internet, and basically that the backbone of the internet also consists of
a couple of large networks that play an increasingly important role. So you could say this is also a form of centralization. Okay, so that's basically how the internet works and how it's working today. Much of what we do, much of the internet infrastructure is invisible. So that again refers back to the iceberg I showed at the beginning. If you look at our digital infrastructure, it consists of several layers. So if you look at the picture on the left, there's of course the users at the top, like citizens and organizations and society at large, which use services and algorithms, which in turn use storage, which in turn use the network. Okay, and that's the red box at the bottom. And all of these components, they deal with data. So the network deals with data in transit, getting it across the network from A to B. Then the storage deals with data at rest, where you store it. And then we have services and algorithms dealing with, that's about data in use. Okay. And as you can see in this picture, the network or the internet is the foundational layer of this entire infrastructure. Okay. And in that regard, I also think it's interesting to watch the video that I highlighted down there, which is by Henning Schultzrinne, who gave a talk at the SIGCOMM 2022 conference on basically stating that the internet is a new civil engineering infrastructure because it has become very large. It's impossible to replace at once. It's being incrementally improved and all that sort of thing. So he draws the parallel between the internet and things like the railroad system or the water system or the road system in a country or a region. Okay. Yeah. So I think it's a very interesting talk to look into. And the picture on the right is basically a similar picture as the one on the left, but a different division of functionality of the digital infrastructure, but again with network infrastructure at the bottom of this stack, so to speak. And the picture on the right also shows various challenges that are currently important, such as manageability. How do we manage the larger network infrastructure, the larger digital infrastructure, but networks in particular? Things like responsibility. So how do we increase the security of the digital infrastructure, but also at the same time make it more transparent and controllable so that folk can really have a say in who's processing their data and how it flows across the internet, for example. And we have things like sustainability, for instance, to reduce the CO2 footprint of IT systems. Okay. But in this talk, I'll be focusing on the bottom layer of these two pictures, so the network and the internet in particular. So a different look at how the internet works under the hood is from a protocol perspective. So what you're seeing here is the famous hourglass of the internet with the applications or services at the top. So that's usually what folks see, like video, Netflix and Facebook and the apps and all that sort of stuff. At the bottom, there's the real transmission technologies that actually get the bits across the wire or the ether. So that's radio and Wi-Fi and Ethernet and all that sort of thing. And then in the middle, there's the components that basically glue the applications onto the network, which are different protocols like the TCP/IP, of course, with BGP, the routing protocol, and all these sorts of things. So the middle part of the hourglass is really about naming, addressing, routing, and transport. So getting the data across the internet from A to B across these different networks. And of course, there's different organizations that run this infrastructure. So my organization, SIDN, is part of it because we run the .NL infrastructure, but there's also a similar organization for .fr, for example, that's AFNIC, and there's basically one for every country. We also have network operators, we have DNS operators, we have organizations like ICANN, the IETF, which standardizes internet protocol. So it's a whole ecosystem that basically spans the internet infrastructure basically spans a whole ecosystem ranging from operators to standardization and policy body. I'm not going to go into much detail here because it would take another hour to explain everything here. Okay, so then security. what is the problem if you do not have enough security in the internet infrastructure? So what I'm trying to show here is an example where a client requests the IP address of a domain name, which is a process that takes place through the domain name system, the DNS. And this is a simplified view of it. So basically what happens is the client queries a resolver and it asks, okay, where is example.net? The resolver then queries the DNS authoritative name server infrastructure, which is a complex beast in itself, but I kind of conflated it to one server here. So just to simplify things, it will return the IP address of the domain name that was being that the client was looking for. So that's 184.216.34. So that's IP version 4, and that will, that will then enable the client to basically contact the remote service because the service works with IP addresses and not with domain names. Okay, so what's important to highlight as well, I think, is that the autonomous system structure is about IP addresses and how to get from one IP address to the other. That's routing. And then there's naming, which basically maps names onto IP addresses because people work with names rather than with IP addresses. Okay. So what this picture shows is that the actual queries do not go from the client to the resolver to the authoritative name server infrastructure directly, but of course they do that through these different types of networks. So in this example, the client connects to D through AS1, AS2, and AS3, and the resolver D connects to the server A through autonomous systems 1 and 6. Okay. Oh, by the way, I included references on some of the slides, so you can check them later on if you want to have more information about this particular topic. So what can go wrong in the routing system, at least, is that AS4, so that's an autonomous system in this particular example, somehow hijacks the traffic of the resolver D. So in this example, which it does by manipulating BGP announcements, and as a result, the client routes the requests of the client end up at this malicious DNS resolver M rather than at the benign resolver D. Okay, so that's the blue line at the top, at the bottom. And as a result, the malicious DNS server returns a wrong IP address, which in this example is 203.0.113.1, which makes the client contact a server that it doesn't want to go, right? So that's a security incident, obviously. So what you can see here is that an incident in the routing system can lead to consequences at the DNS level, and then later on at the level of the service that this client connects to. Okay, so this is an example of how insecurity at the infrastructure level might have an impact for end users. Okay, so this is basically how the internet works from a 10,000-foot perspective. Obviously, I left out a great number of detail. And now I have some slides on the role of SIDN and SIDN Labs in this space. Oops, excuse me. So we are the operator of the .nl top-level domain, which is the national top-level domain of the Netherlands. We're a not-for-profit organization that works for the benefit of Dutch society, and our key role is to securely manage the .nl infrastructure, so that the .nl domain namespace, which means that we store all 6.3 million domain names in our database, and we also make that information available to the internet through the DNS. So through this autonomous, through the authoritative name server infrastructure that you saw in the previous example. Because of our central role in the internet, we've been designated as a critical service provider by the Dutch government. That's because we manage the infrastructure, and the DNS infrastructure, and the 6.3 million .nl domain names. And our goal is basically to do just that, but also use the the surplus of our income to invest in the value of the internet in the Netherlands and beyond. So it's really a dual role that we have. One is to securely manage the .nl top level domain, and the other one is to invest our surplus in increasing the value and the security of the internet infrastructure. So the picture on the right shows that we are actually three different units. So we have SIDN, which is the operational heart of our company, and we have SIDN Labs, which is the research team, and I'll be speaking about that a little bit more later on. And we have SIDN Fund, which is an investment fund that invests in new projects for the benefit of the Dutch internet community. And actually, that's the core goal, the core target group of all of the three units. We all work for the Dutch internet community, and of course also for the global internet community. Okay. So this is a rather busy picture. I'm not going to explain everything, but what this picture is trying to show is that at SIDN Labs we work at different we have different topics that we work on. So we work on the DNS, for example. We also work on BGP, so that's the routing system, and we also work on other core internet systems such as the time system. So some of our projects are long-term, other ones are medium-term, and some are short-term. And there's a few examples in this grid here, but I'm not going to explain them all. The key thing here is that we focus on the core of the internet and trying to improve its security there. Sometimes our projects are really long-term, and sometimes our projects are short-term. So one long-term development is that of how to make the internet infrastructure quantum safe, so that the crypto algorithms that are being used can withstand the quantum computer that's maybe happening in a decade or so. And I think that this was the topic that the speaker Roland van Rijswijk spoke about last week. So that will be a long-term internet security topic. Okay, so different topics, different timescales. That's basically what that picture showed. And then this picture shows our position in the space of operations on the right and the academic community on the left. So what we're trying to do is work a lot with academic institutions like the University of Amsterdam, the University of Twente, the University of Southern California, so quite international. And at the same time, we work with the operational community. So in our interaction with the academic community, as an example, we share our domain expertise, so expertise about the operational side of the internet. We share, we provide investments for the universities to carry out research projects, and sometimes we also, we have embedded researchers that spend one day a week at the university to build a sustainable relationship with the academic community. And in return, we sometimes get students who do their master's degree with us. We get a better understanding of emerging technologies that folks at universities work on, and we also get feedback on our proposals from an independent community. So that's really a value exchange, you could say, between us as an applied research lab and the academic community. Okay. And I should also highlight that we also share everything that we do with the internet community, because SIDN is a private organization, but we have a public role because we manage the .nl top level domain. So this means that we also share everything that we do through our website with the internet community. That's basically the interaction that you see going from top to bottom there. Okay, so in this way, we're trying to bridge these two worlds we're trying to make a bridge between the academic community and the operational community. Okay, so I selected 7 case studies just to show how we do that, the bridging of the academic community and the operational world. They're just highlights. There's more information on our website, sidnlabs.nl, so feel free to go and check it out. The information is both in Dutch and in English, so you should be able to select your favorite language. So our first case study is what I called online impersonation. This is about a tool that we developed called Logomotive, and it basically crawls the entire .nl zone looking for websites that use logos illegally. So, for example, there are known cases where phishing websites use the logo of the Dutch government to kind of make the website look more trustworthy. And what we did is that Logomotive basically takes a screenshot of all the sites in the .nl zone and looks for logos that on websites that should not be there. Right? And we ran 2 pilots using this system, one with the Dutch government and one with Thuiswinkel Waarborg, which is a Dutch quality brand for online web shops. And the results of these 2 pilots was that we discovered several sites that were using logos illegally. So, for example, we found these phishing sites with logos of the Dutch government, but we also found sites that were benign. So, benign sites belonging to the Dutch government, but the Dutch government wasn't aware of it, wasn't aware of these websites, and that they were managing them. Right, so that was also an important finding because this would enable the Dutch government to take control over these sites and also manage their security better. Okay. So and what we did is that we included Logomotive as part of our brand guard service, which is a service for brand owners who want to protect their brands, and that's now part of that service. And we also published a peer-reviewed paper at PAM 2022 plus a few blogs. Okay, so this is an example of a tool to detect online impersonation and as a result reduce abuse in the .nl zone. And that was our primary objective. So case study 2 is kind of similar. In this case, we tried to find fake web shops. That was a big problem back in 2016, 2018. So we use a tool that, again, scans all the .nl domain names and looks for things like MX records and registration times to make an assessment of whether a certain website is a fake web shop. We did this together with ICS, which is a credit card company. And as a result, we came up with, the tool to detect these fake web shops. And we also took many of them down. So there's a table there in the middle that shows how many shops we found over time. So in 2018 there were around 12,000, and this year was 192. And we also managed to take these web shops down, which is something that we do together with our registrars, which are the folk that are actually selling the .nl domain names. So this was actually something that helped increasing the safety for users and also helped increasing the security of the .nl zone. The result, we integrated the result in a dashboard that is being used by our anti-abuse desk, so they can easily spot these kinds of sites and work with our registrars to take them down. And we also had a peer-reviewed paper published at PAM 2022, PAM 2020. Sorry. Okay. Then we have an ongoing project called the registration checker, which basically checks new .nl registrations for suspicious behavior. So, for example, if there is a suspicious string that's being registered, or if the address of the registrant appears to be incorrect. And our goal here is to find potentially abusive registrations as soon as possible. And we currently have the picture, the slide shows how that works in a bit more detail. But basically what this resulted in is what we call a production prototype that also runs in our production environment and is being used by our service desk. And it enables them to quickly spot these potentially suspicious registrations. The system uses a machine learning model based on abuse reports that we received from a third party, Netcraft. And the user interface gives hints to the abuse desk people that work at our office. And we're currently planning a follow-up project in which we team up with the Registry of Belgium, so that's .be. And we would like to make this available to the entire European CCTLD community, which is part of the Center community. So that's the trade organization for European CCTLDs. CCTLD, I should say that this means country code top level domain, which is .nl, .be, .fr, so a TLD of a particular country. Okay. Another example of work that we do is how we deal with Anycast. So Anycast is a technique that enables you to basically announce the same server at different places on the internet. And as a result, you increase availability because depending on where you are on the internet, you end up at server A or at server B, whichever is closest, depending on what the routing system thinks is the closest node. We use Anycast heavily for our DNS infrastructure. So the DNS infrastructure is entirely Anycasted, and we have developed a testbed that enables us as well as our academic partners to experiment with Anycast setups. Okay, and the Anycast testbed currently consists of 30 sites across the globe, and it enables us to dynamically add and remove Anycast nodes, and we use it for various purposes. So to experiment with DNS based with Anycast-based DNS infrastructures, but also for time services and such things. And we also developed a heat map where you can see which nodes, nodes in the testbed are being, served, which nodes in the testbed are serving which clients and where they are from. So in the picture at the bottom right, you can see this is Amsterdam, I think. Yeah, so that's the Amsterdam node, and you can see that there's a lot of traffic coming from Western Europe, but apparently the Amsterdam node is also serving traffic from India and from South America. Okay. So you can check it out at this link that I put there. And this whole infrastructure, so the Anycast testbed was also used as a blueprint for the production Anycast system that we use at SIDN for the .nl name server infrastructure. And it's also being used by measurement projects with our academic partners. Okay. So along those lines, one of the key research topics that we're engaged in is large-scale DNS measurements. So we did a lot of measurement studies over the past 6 years to better understand basically the infrastructure of the DNS and how we could better engineer it based on those measurements. And we summarized those studies in an RFC, which is RFC 9199, which was published earlier this year. And we basically use the measurement studies in that we report on in that RFC to improve the management of the engineering of SIDN's DNS infrastructure. So for .nl, so for example, we used it to recommend to our operational colleagues to discontinue unicast servicing and entirely concentrate on Anycast, which was a recommendation based on RIPE Atlas measurements that we did on the internet. And we also used our measurement methods in a similar way to map the resilience of the DNS infrastructure of the Dutch government. Okay. And other things that we did, we also developed tools, which is what you see at the bottom of the picture, for DNS operators to better monitor their DNS infrastructure. Okay. So that was on large-scale DNS measurements, and the other component that we're working on is time services. So time services are actually very much an unknown component in the internet. but at the same time, they're crucial for security because you need time for signatures, for example. So for DNSSEC, which is the secure version of the DNS, or for one-time passwords. So it's being used all over the place. But we noticed that public NTP services are often poorly documented. So, for example, it's not always clear what kind of time sources they use. Do they use GPS or Galileo or something else? And what support levels they provide. So what we did is we set up TimeNL, which is what we call our transparent NTP service, which does have all that information, and we publish it on time.nl. So that's a public website that you can check out. And we have a secure version of the of TimeNL, which is nts.time.nl. We have an Anycasted version using the Anycast testbed that I showed on one of the previous slides. And of course, we have a standard NTP instance, which is based at our office in Arnhem. Okay, and actually, the NTP infrastructure has become quite popular, and we're currently serving more NTP traffic than we are serving DNS traffic for .nl. I didn't have the numbers when I wrote the slides, but I'm sure it's more than the DNS traffic for .nl. Okay. Oh, by the way, the picture on the top at the top right is my colleague Marco, who's the mastermind behind all of this, and he's actually sitting next to the antennas that we have on top of our building, which is a GPS antenna, Galileo, and DCF77, which is a radio signal coming out of Frankfurt, also with the time encoded in it. So if we look a little bit further with the TimeNL work, so the NTP work, we actually envision something that we call TimeNet, which is it's a concept right now, but we're interested in carrying out pilots with this concept. So if one of you guys are interested in this topic, please reach out and we'll discuss to see what's possible. But what we envision is that we'll have multiple what we call assured time sources, which are the blue servers on the left, which have what we call a holdover clock. So a holdover clock is an atomic clock that can work without an external time signal. So usually the time signals, they come from satellite systems like GPS or Galileo, or they come from that system I just spoke about, DCF77. But sometimes there is there can be disturbances. So there could be radio jamming, or maybe there is an outage. Maybe there's the satellite infrastructure might be hit by something, and in that case, you want your infrastructure to survive these kinds of disruptions. So in that case, you can work with the blue servers, which have an internal atomic clock that can take over from the external radio signals, and it can continue to function for, I think, about a month or something without the GPS or Galileo information being available. Okay, so that gives a more resilient and trustworthy time infrastructure. And our thinking is that perhaps we could share that time. We can share those time signals through the PTP protocol, which is a very precise timing protocol across a layer 2 network. So that's the example you're seeing in the middle. So multiple network operators interconnecting their network at layer 2 and feeding that information basically into the server on the right, which could be an ISP, and they could then use the PTP timing signal to serve normal NTP clients. Okay, so that would mean time as a service for the ISP in this case, because they would no longer have to provide antennas and holdover clocks and all that sort of thing, because they kind of delegate that to the assured time sources on the left. Okay, so this is something that's in the making, so to speak. So we're thinking about the concept as we're showing it here in this picture, and we're looking for pilot partners to work with us to experiment with this concept. Okay. So my final case study is the DDoS clearinghouse, which is a system that we are developing with a bunch of partners in the Concordia project. That's a European project. And the goal of the system is to increase the level of proactiveness in DDoS mitigation by sharing information about DDoS attacks amongst different organizations. So the thinking is that if an organization gets hit by a DDoS attack, so that's a lot of incoming traffic that basically cripples your regular service, then the organization needs to mitigate that attack, obviously. But they could also make a fingerprint of the characteristics of the attack, such as packet size and IP addresses and inter-packet interval, protocol type and that sort of thing. And they could put that information in what we call a signature, and then share that DDoS signature with other organizations, so that these other folk already know, okay, this guy is being attacked by this kind of DDoS attack, so they can already prepare their networks for that kind of attack, right? So for the victim, it's still reactive because these folks need to handle that DDoS attack. But for the other organizations who receive the fingerprints, it's proactive because they can already prepare themselves for the attack if it hits them next, right? So what we did is that we carried out the work with a bunch of partners in the Concordia project, and we set up a technical pilot with the Dutch Anti-DDoS Coalition, which is a group of 16 organizations in the Netherlands who have teamed up to jointly fight DDoS attacks, and they are going to run this DDoS clearinghouse to share information on DDoS attacks amongst each other. Okay, and we're currently trying to put the system into production at one of the Anti-DDoS Coalition partners, which is NBIP. We also set up a test bed that enables folks to experiment with this whole setup as often as they want. For example, they can use it for training purposes, and that's in Concordia speak, that's called cyber range, which is actually complementary to the large-scale DDoS attacks that we carry out in the Netherlands every 6 months. Okay, so you don't have to wait for the next DDoS drill or exercise. You can, using that test bed, you can go through these scenarios anytime you want. Okay, and we'll be summarizing all that in what we call the DDoS Clearinghouse Cookbook, which will be published at the end of the month, because that's when we need to deliver it to for the Concordia project. Okay. So I also included a few slides on our vision on the internet going forward. So we gave a few presentations about this topic in the past. And it's something that we're currently working on in a project called Catherine. I'll be talking about that in a little bit more. So our thinking is that the internet will need to evolve into something that we call the responsible internet, which means that we add two properties to the properties that the internet already has, right? Because the internet, as we know it today, it's an open and generic platform, and it's also being characterized by its distributed and decentralized nature. And our proposal is to add transparency to that, as well as controllability. Transparency basically means that users or relying parties in this picture have more insight into into the composition of the internet. So they kind of get a map of the internet, and they know, based on that map, they can see how their data travels through the internet, for example. Okay. And with controllability, it's actually the complementary part to transparency, where relying parties are able to actually steer traffic in a certain direction. So maybe around certain networks that they don't trust. Okay. And our hypothesis is that these new properties, so these two new properties, actually would benefit quite a wide range of users, so individuals, and we also think of critical infrastructure operators, network operators, and policymakers. So just to pick one, which is critical infrastructure operators. So if you are an energy grid, for example, and you need to remotely control, sensors in maybe how you call that, energy distribution points, then you may want to have more control over, more insight into how your data travels across multiple domains toward these sensors in the in your network. Okay, and you may also want to have some control over which networks actually handle that data. So that's one of the scenarios that we're thinking of. Again, I included a few references at the bottom of the page, so you can check out more if you want. So, and to kind of get a better feel for how this would potentially work, we developed a system called the Path Visualizer, which basically builds on Traceroute, the standard Traceroute tool that's built into the internet infrastructure, to show how people's data travels through the internet. Okay, and it's basically a user interface for Traceroute, you could say. Okay. Oh, what's interesting is that this tool also dynamically generates alerts when there's changes in the path across different autonomous systems, and we'll be making it available as an open source tool later this month. So what we do as well is that we experiment with a system called Scion, which is what they call a clean slate architecture, being developed at ETH in Zurich, and this clean slate architecture also tries to introduce properties such as transparency and controllability. And what we're trying to do is, can we use the Scion concepts in the internet as we know it today to improve internet security? So, for example, to provide more transparency as to how your data travels across the internet. So what we did in this space is that we implemented the Scion protocol the Scion data plane protocol in P4, which is a programming language for networking hardware. And we're also teaching students about these concepts to basically widen their horizon beyond how the internet looks today. So there's a complex picture on the right showing how Scion worked, but I think that's kind of out of scope today. So this project that I spoke about previously is the Catherine project, and the goal of the project is to set up a small-scale responsible internet, so an internet with more transparency and more controllability. It's being sponsored by the Dutch Science Foundation, NWO, and it consists. We managed to hire 7 PhD students. The kickoff of the project is next week, so it's quite timely for this presentation. And one of our goals is to design and prototype network descriptions that will make the network infrastructure more transparent, and experiment with it through test networks. We already have a test network, which you can see on the map of the Netherlands on the right, and it interconnects 6 different sites using P4 switches. And in addition to developing the network technology, we will also develop value-added services on top of the network, and experiment with these, and also check with network operators how these services might enhance their service offering in the future. Okay. Oh, and we also work with Waag Society, which is one of our partners, to validate this concept with end users, because we are unsure of how what mental model users have of the internet. Let's say making the internet more transparent might also be a shock to some users. So we also want to figure out how we could do that, and how we could inform them in a responsible way. All right, so a little bit of vision beyond this Catherine project. So I think that in the Netherlands and also in Europe, it's important that we have a strong technical internet community, because the internet is invisible, but as I tried to show at the beginning, it's an essential part of our digital infrastructure. So it's something that everything else builds upon, and I think that we need an internet community with a clear vision on where the internet will be going, and maybe the responsible internet is one of these potential directions. To expand a little bit more on that, you could perhaps envision a responsible internet such as the onion model on the right, I would say, where you have different how can we put that, different security zones, if you will, or security scopes, where in the in the middle of the onion, every network trusts each other network. Then there is a layer beyond that where the trust is a little bit lower, and then there's a best ever trust layer at the end, which is comparable to the internet as we have it today. And the level of transparency and control that we envision for the responsible internet could vary across these different levels. So for example, in the middle of the onion, everything could be transparent and controllable, and the network operators trust each other and would also make that information available to each other. It will be a little bit less in the second ring, so to speak, and it will be even less in the third ring. Okay, so this is a potential new way of looking at the internet of the future and adding these properties of transparency and controllability to it, in combination with these different, in this case, the 3 different security scopes. Okay, so that might be a potential, view on the future of the internet. So in addition to having a strong technical internet community, I think we also need, facilities for the academic and industry communities to experiment with new internet concepts. So one thing that would be interesting to have would be an open data platform where we can carry out measurements and also store those measurements and analyze them and be able to use them for experimentation, as well as an open and perhaps nation or European-wide network that we could use for for developing these kinds of networks. And finally, I think that one other thing that's important is that the IT, that IT education should also pay more attention to more, softer elements such as societal values and digital autonomy, in addition to all the technology that we currently teach at universities, because the internet is actually part of a socio-economic ecosystem. So just doing the technology is no longer enough. All right, so my last slide is basically a few lessons learned that, at least from my side, and that I wanted to share with you all. So maybe, because maybe I think they are interesting for you guys as well. So if you define problems for your research proposal, try to define them in combination with users/domain experts. So that's something that we did for the logo detection project, for example. So we are not experts in logos. We're not experts in credit card transactions. So that's why we tried to team up with other folk who are, and that actually worked quite well. Another recommendation from me would be to set up a long-term relationships between academia and research labs. So for us, it's obviously relevant to have long-term relationships with academic institutions, but I'm guessing that the other way around might also be very interesting. So to give you an example, we're part of the Tucker Research Institute at the University of Twente. And this is basically a combination of university researchers and industry organizations trying to learn from each other. So I think that these kinds of constellations are really important to be able to transfer results from academia to industry, and also get practical questions from industry back to academia. One other lesson I learned is, if possible, try to combine scientists, engineers, and operators, preferably in one team. Okay. And this is pretty easy at SIDN Labs because we also have an engineering department, and we have an operator team, so we can basically team everyone together quite easily. But I think it would also be interesting to do this, across organizations. Also, in terms of collaboration, I think it's important to have a research network, either on your own premises or jointly with other organizations. So we have our own network here at SIDN Labs that we can experiment with, which is separate from our production network. But we're also part of this test network that we use for our future internet research. So that's the map that I showed a couple slides back, where you saw the map of the Netherlands with the network mapped onto it, and that's a joint research network. And one of the key principles that we live by is that we make results not only public, but also try to make them generic so that they're widely applicable. So for example, the RFC 1991-99, that's something that we wrote for all DNS operators out there. So it's actually quite a large user group. But then we also apply these results ourselves at SIDN. So it's the famous term of eating your own dog food or drinking your own champagne. I think that's the more current term that folk use. And finally, at least from my perspective, keep in mind that the peer review of publications is a means, not a goal. So for us, as a applied research organization, we use peer-reviewed papers to basically verify the quality of our work with the community and also verify that we're working on the right topics. Okay. Of course, we're not an academic institution, but yeah, I think that this is something to keep in mind if you work with industry partners, that they might give a different weight or different purpose to scientific or peer-reviewed publications. Yeah, so that basically sums up my talk, and I'll be glad to answer any questions that you guys have.
Thank you very much, Christian. I will just switch to my camera 1 second. This one here, wonderful. Good. Close that. Okay, perfect. So we also see Akin, and we don't see Alex. We don't see you yet if you're already there. So yeah, thanks a lot for the great talk. I really enjoyed it, and especially enjoyed it because it's a lot of the stuff that I'm also dealing with for many, many years about the internet, how it works, and that it's really the backbone for the cybersecurity. So thanks for that, and also thanks a lot for sharing a little bit more about this SIDN Labs, which is a very interesting structure. And when I presented you at the beginning, I was thinking it's quite cool which different roles you have, and all these different roles, they require quite some different skill sets, and therefore giving the others a little bit more time to arrange the questions and organize those. Could you share just a little bit about your personal journey? So where did you start, and where did you acquire the skills, and how did you end up in the position where you are right now?
Oh, okay.
Yeah, and maybe also like sharing a little bit about what influence zones do you have now? Because with the NLnet, you clearly have certain aspects with the SIDN, with your profession at the University of Twente.
Yeah.
So you've quite some you have quite an interesting standing.
Yeah, so that's an interesting question, Mark Oliver. Thank you. I hadn't thought about that before, to be honest. But basically my personal goal, if you will, or my personal mission, is to increase the security of the internet infrastructure, and I do that through SIDN Labs, but I also do that through other organizations. So, as a member of the board of NLnet Labs, I kind of do the same stuff, but not as a researcher, but as a board member. Okay, but you are still able to contribute to the security and resilience of the internet through that role. Similarly, in the Tucker initiative, I take the role as researcher, also trying to contribute to the security of the internet. And the same goes for my role at the University of Twente, which is also about the security and stability of the internet. So the theme is actually the same across these different organizations that I'm with, but the angle is slightly different. Okay. So at SIDN Labs, it's applied research. At the university, it's academic research, and it's supervising students and all that sort of thing. At NLnet Labs, it's more board level discussions. And at Tucker, it's mostly about a combination of research and industry. So it's different aspects, where I'm all trying to contribute to the same high level goal. My personal goal, which happens to fortunately align with what I do at SIDN Labs and the other organizations. Mm-hmm. Yeah, so that is kind of what I'm trying to accomplish. And well, where I came from is, well, I studied computer science back in the day, and then I worked in industry for about 2 years. So I used to work for Alcatel-Lucent well, back then it was called Lucent, but then a couple of years later it was called Alcatel-Lucent. I think now it's part of Nokia. Where I worked on telephony switches, but also on what was then called WaveLAN, which is the predecessor of Wi-Fi. And then I left the industry to go back to a research institute to do my PhD. And then after I did my PhD, I was asked to lead a project because a colleague left to another company, and I had never thought about about project management before. And this is how I kind of fell into the role of project management and managing research. Yeah, so I spent a couple of years in that role, and then I moved to SIDN, where I became a member of the management team, set up SIDN Labs, and it moved on from there, so to speak.
Very good, very good. And which are the more so now we have a little more understanding of your roles, and which would you say are the most important skills for your daily work on improving the internet and making it more resilient and so on? Is it like being able to talking to people, to bringing the right people together to discuss? Is it to be the expert in the technical solution? Is it a combination of all of those? Is it something totally different?
No, I think that, well, being able to talk to people, I think, is actually crucial. And it's one of the key things, I think, is to try to back off from the details. So I trust everyone in my team everyone in my team has a better knowledge of the details than I do, right? And I trust them in that. And that's a trust you need to have, because if you don't have that, then you will not be able to make the abstraction and to think about what you do at a higher level. Okay. So my role really in the team is to do two things: is to help guiding the team in terms of strategy. So which are the important topics that we need to address? Okay. And my other role is to help my team to get stuff out of the way that they don't want to do, like doing contracts and all that sort of stuff.
Yes.
Okay? So I'm trying to position my team so that they can do the things that they like and that they're good at.
Very good, very good. Yeah, so with that very valuable info also again for you as a persona and of your roles, I hand over to Alex and Erkin for the first audience questions. And in this Q&A, I always kick in from time to time to deepen some aspects, to ask some additional stuff and so on. Yeah.
Sure.
So who starts?
So, Dr. Kabil?
Yeah, I'll start. Okay, I just have to find my notes. Okay, thank you, Cristian, for this presentation, which was quite broad and quite precise at the same time. Do you hear me well? Or
yes.
Okay.
Yeah.
Okay. Nice.
Thank you.
Perfect. So I think I will begin with more general questions about the internet, because you've made lots of precisions about it. And the first one was, what is the biggest threat for the internet? So if it collapses one day, what will be the most suspicious cause? And in the same with the same aspect, another question, which was, which are the bottlenecks of today's internet?
Okay, that's a very interesting question. What are the biggest threats? Well, there might be a few actually. So it might be from an operational perspective. So to give you an example, when this Nord Stream 1 and 2 incident happened like 2 months ago, I was called by a journalist, and the person asked, okay, this can happen to a gas pipeline, an undersea gas pipeline, so it can also happen to undersea internet cables. I was like, yeah, it can. Then he asked, okay, what are the consequences if you kind of disrupt 1 or 2 or 3 of these cables? What are the consequences for the internet? I was like, I have no idea. So I think that planning for large-scale internet incidents would be an interesting topic to explore. And I know that there's research on that at the University of Delft. So that's Professor Fernando Kuipers, who's working in that space. And I think that these are that this is something that we need to better understand what can happen in crisis situations. So I think that so these kinds of large-scale infrastructure incidents, they might have effects that we don't understand at this point. Also, I think that the other problem or challenge is to secure the internet routing system. So currently, we're working with folk are trying to introduce RPKI to protect routing announcements, but it hasn't been deployed everywhere yet. So this makes the internet still quite susceptible to routing hijacks and all kinds of other malicious things. So I think that in terms of major security incidents, I think that the routing system is really the core of the internet, and that's something that we need to really protect well. The other threat, I'm not sure if it's a threat, depends on how you look at it, is that so the picture that I showed all the way at the beginning somewhere, where you see the wide area network that Google has put up. So that's a network that they manage, right? And other organizations like Facebook and AWS, they have something very similar. It kind of changes the model of the internet as we know it today, right? It's again referring back to this blog that Jeff Houston wrote, I think in 2016. He calls it the death of transit, which means that the number of network hops between the source and the destination get reduced because of these wide area networks. And in principle, that's a good thing because you reduce network latency, and you give more control over the traffic that travels across the internet because they're mostly handled by one organization. The downside, I think, is just that you might end up with an internet that consists of a few large wide area networks plus a bunch of networks that do the internet the old school way, so to speak. And if you look at, so I recently read a paper, actually that's quite interesting to look at. I think it's called 7 Days in the Life of Offnets, where they talk about that 50% of the internet traffic currently is handled by these large wide area networks. So you can already see that the internet model of interconnecting different networks to form a chain from the source to the destination is changing quite a bit. And the risk I see is that you again end up with concentration because we already have concentration at the application level. So with Google and Microsoft and all that, we have concentration in the DNS with the large public resolvers. Again, Google public DNS. There's the Cloudflare DNS, the DNS infrastructure. There's Quad9. There's also concentration in the DNS on the authoritative side because many of the new GTLDs are being operated by the same organization. And now there's also kind of a concentration going on at the network infrastructure side. So what I'm seeing is concentration across all levels of the internet infrastructure or the digital infrastructure. And that worries me a little bit. Because, and it worries me because the original design of the internet had one key principle, which is the internet should be in the hands of many. Because if the internet is in the hands of many, that increases diversity because everyone uses their own systems and software and all that sort of thing. And if you use diversity, then you increase resilience. And that's my concern, that this concentration at all these levels reduces diversity and also reduces the level of, well, what people in Europe call digital autonomy, meaning that it reduces the level at which you're in control over your digital infrastructure, which is something that our society increasingly builds upon. That was maybe a long answer.
Quickly kick in here. So it's quite an interesting point because I would spin the thought further, saying like, okay, it's an optimization question. So what do you want to optimize? And when we look at producing things, we also saw the tendency that production moved to China because it was cheaper. And maybe the reason for the concentration obviously is for the companies it's cheaper that we have it, and also we have lower latency and so on. So but it's, even though this is like valid optimization goals, the resilience goal is the one that people don't take care of at the moment. Therefore I find the remark very, very good. And talking about this concentration, There's Elon Musk that is concentrating lots of activities like Twitter recently, but I don't want to go for that one. I want to go for Starlink. So this is, for me, quite an interesting infrastructure because it's for a long time the first time that I see we have an additional physical link that is around the globe that is doing something. I mean, we had undersea cables, there were more cables, faster cables, and so on. But as from your experience or from the measurements that you're already taking, is Starlink already making a change? Will it make a change in the resilience of the internet, maybe, but also in the way we think about the internet, talking about latencies, time synchronization, and so on? Because for these satellites and these massive satellites, all these problems are also there, or they're even more there. So does that play a role in your considerations for the institute or in the research?
No, not yet at this point, Mark Oliver. So I haven't experimented with Starlink yet, but my colleague Roland van Rijswijk, he has. So I think he would have a more better, founded opinion in this regard. So I don't know. I haven't really looked into this space yet.
Okay, cool. Because I was also not thinking about it necessarily as an internet service provider, like an access node, but rather as it's really an additional layer of resilience that is there.
Yeah.
That might do something if all these cables go down and so on. Because as you said, to just mention it once again for the audience, so this concentration to fewer entities like Google, Facebook, and so on, then more efficiently using the cables by reducing the number of cables and so on. If something is hit, it's hit, and it's hitting massive because we have multiplexing and so on. Okay, back to
Okay, yeah, thank you for this exchange, because there were some questions about this kind of neutrality of the net and the centrality of some nodes. So I think we can just jump on it now. For instance, there were questions about, I will try to find them again. It was not my list, but yeah, as I said, Mark Oliver, maybe the centrality of the web, is it a weak point or a strong point of the security of internet? Is it better? And what is, if we speak about the sustainability of the digital technologies, what is the cost of a lot of analytics we are flooding now, circling on the networks? And what is the cost between Googling a website to access it, whereas going directly to the address of the website? So lots of questions, but yeah, it was more about, is the centrality a good thing or a bad thing, to make it very small?
It depends on. I think it depends on who you ask. So if you're if you're an organization, so as an example, if you're an organization that wants to outsource their DNS infrastructure to someone else, and because you don't have the staff or you think it's too expensive or whatever, then you could outsource it to Google, for example. They have a service offering that enables you to use their Google public DNS service to replace your local DNS infrastructure. Okay, so if you're a company. So from a company perspective, that's a great thing, because you lose your infrastructure, you reduce costs, plus Google is a very large company, so if there are new protocols or new security mechanisms, they can roll them out for, let's say, all of their customers at the same time, right? So you don't have to wait for network changes very long. So that's more of a, I would say, a micro perspective. But if you look at it from a macro perspective, so from society, so from a country or maybe a region like Europe, then it might be different, because you see a lot of concentration, and then it means you have a dependency on just a few organizations. And I think that the parallel that Mark Oliver is just trying to draw with, the real world is actually quite interesting, because we saw during COVID what it means if you're totally dependent on one supplier for, mouth masks, for example, which had to come from China, or if you are totally dependent on your energy provisioning on one country, Russia, in many of our cases. Okay, so I think that resilience in general is a good thing to have, but resilience at not only at the micro level, but also at the macro level. And I think that at the macro level, it's really, I think it's an important role for governments there to also have a say in that. So not that they need to, you don't want them to actually run the networks, but they could provide the the frameworks for folk to set up their infrastructure and think about, okay, what does it mean for at the macro level if I outsource something to one of these big technology companies. So I think it's really a difficult question to ask, and it depends on your perspective if centralization is a good or a bad thing. But if you ask me as an internet internet geek, then I think centralization is not a very good thing. Yeah. Although I can understand that companies want to outsource some of their activities to these large organizations because it's cheaper and easier.
Sure, the internet has known lots of changes, and this one the biggest, I think, during this last decades of even 30 years. Okay, so more questions. These questions that are, I would say, complementaries. So what is the most promising internet research happening outside of your institution? And what is the most promising internet research happening inside your institution? The question was not like this, but this was the idea of the question.
Or if you don't want to judge like on promising, you can also say disruptive or something like that.
Yeah.
It's like a more neutral criterion for selection.
Yeah, I was thinking about the answer. I think that so one topic that we want to investigate as of next year is also the topic that Roland van Rijswijk spoke about previously, which is how can we incorporate quantum safe encryption algorithms into the internet infrastructure, because I think that will have a huge effect not only on the DNS but also on other parts of the system. And I think that in the end, you may want to have more. So the Scion people, which are these people that work on the Scion network infrastructure, they introduced a concept that they call algorithm agility, which means that you can quite easily replace algorithms and security encryption algorithms in the internet infrastructure, and they have certain concepts to do that. And I think that having this agility in place might also be one of the key challenges for the internet going forward. And then specifically in the relatively, more short term is how do we get these quantum safe encryption algorithms rolled out? Because we know, so a colleague of mine, Moritz Muller, he has done his PhD on how to further secure the DNS. And one of the things that he looked at is, okay, how long does it take to standardize a new encryption algorithm for the DNS? And it turns out that this is, he looked at how long does it take to deploy a new encryption algorithm for the DNS. And it turns out that this is kind of 5 to 6 or 7 years, something in that range. And that's because you need to first come up with the technology, then standardize it in the IETF, which takes quite a bit of time. And then you need a significant amount of deployment, which takes time as well. So these very long timelines, the question is, do you really want that in the future? If our society increasingly depends on the internet, you may want to have an infrastructure where this level of agility increases so that you could change algorithms, I don't know, maybe in the space of weeks or something like that. So I think that is one of the interesting things to look at, that is both happening outside of our institute as well as inside.
And this is also an interesting point, because it again goes with this centralization and decentralization, because for having like a central distribution point for these updates and so on, and also for cybersecurity incidents and so on, like from the logical point of view, not necessarily from the resilience physical distribution point of view, makes a lot of sense, because we want to share these things and we want to roll them out fast, and at the same time we want to be decentralized with always on or partially on connectivity and so on. Yeah, so quite interesting.
Yeah. And so maybe that's also why you need to, so that picture that I tried to show on one of the last slides with the the onion model of the internet, maybe that's something that would be interesting, because you introduce different scopes, and within a scope you can have different capabilities. So for example, within the inner circle of my onion, you could have maximum algorithm agility, where you could change the algorithms maybe in, I don't know, a day or something, because this part of the infrastructure is being used by critical services for society, like the energy grid or autonomous driving or that sort of thing. And then the second, ring would be, maybe it would take a bit longer there, because it's organized differently and because other services are using it. And then in the third ring, it's what we call the public internet today. It might take much longer to change these algorithms. So I think the concept of scoping or a scope is something that is currently lacking in the internet, because the only scope that we know is the global internet. Okay. And these folks at Scion, they also think that they call it differently. They call it an isolation domain, which I think is not the right term. But I think the concept of having a scope and being able to do things within a scope, so that's a set of networks, a subset of the entire set of networks, that's actually quite interesting. And that might also be relevant for the infrastructure going forward, if it also needs to support critical services like energy grids and remote surgery and all that.
Okay.
So maybe we also need new concepts in the internet infrastructure to support these kinds of applications. That's what I'm
Which
trying
leads
to
to
say.
my next question, which is exactly this kind of question. What is the predominant service architecture today? Cloud computing or edge or whatever exists?
Actually, I don't have any data on that. What I do know is that so if you look at the .NL name servers, then roughly 1/3 of the queries that we get are coming from the hyperscalers. So Google, Facebook, and all that sort of thing. So we do see some concentration in the DNS, because many clients are sitting behind these networks. But I'm not a cloud specialist, to be honest, so I wouldn't be able to discuss it confidently in detail.
Okay, thank you. So back to you, Mark Oliver or Erkin for
Yeah, let's
another
hand
batch of
over to
questions.
Ekin, so that he also has some minutes for his question, for taking over some of the questions from the unit.
Okay, I would like to also thank Professor Hesselman. It was a really interesting presentation and now the discussion. And I would like to pose the audience questions, take advantage of being a moderator and ask my question. So there was this idea about content-centric networking, information-centric networking, getting away from host. What happened to that idea? It's faded away, still researched, happening, or it will be future?
Yeah, that's a great question. Well, that's something that was developed back in 2014, 13, something. I must admit I haven't followed it closely, but there's a test network. So if you go to ndn.net or ndnnetwork.net or something, there is a website. You can have a look at their test network, which is still active. And there is also a research group in the IRTF. So there's the IETF for doing standards, and there's the IRTF, which stands for Internet Research Task Force, where they actually have a group on information-centric networking. So folk are still looking at it. But if I look at, there have been many different clean slate architectures, as they call them, since I think the 1990s, but none of them have really taken off. I think that the two promising concepts that I'm seeing are Scion, which is, well, like I said, it has these network scopes and the concept of algorithm agility and all that sort of thing. And we're now trying to investigate how we can incorporate these concepts into the current internet architecture. I think that this is an important development because they have an operational network, they have an active community working on Scion, and they also implemented Scion at various companies, right? So I think that the banks in Switzerland are currently being interconnected by a Scion-based network. So there is some deployment there. So that's why I think this has demonstrated relevance. Let's put it that way. And the second initiative that I find very promising is more at the architectural level, which is called the Extensible Internet. That's being developed at UC Berkeley by Professor forgot, Scott Shanker. You should check that out. And they basically say, well, maybe we need an internet that is that can support different addressing schemes. So because currently we can only support one addressing scheme, which is IP address based, so IPv4 or IP version 6. And the other concept that they have is what they call in-network processing, where they propose to kind of the content processing that these CDNs do, like load balancing and connection termination and all that sort of thing, to kind of embed that into the internet architecture. And I think that is an interesting concept as well, because if you would have that, then these content distribution functions, which are really vital to how we use the internet, would become part of the internet infrastructure and would be available to everyone, not just to the operators of these large content distribution networks. So in my mind, these are two promising approaches, but of course, that's just my opinion.
Yeah, very, very good answer indeed. Yeah. Okay. Well, so towards the end of our talk, actually, we also try to cover some non-technical questions as well. So among our audience, we also have, some senior researchers, but as well as PhD students, master, or even bachelor level students. So my question would be, in general, how do you research? Or maybe what are your tips for a successful research?
Oh, that's quite a broad question. Actually, I think my key recommendation would be to clearly articulate the problem that you would try to solve. And in one of my recommendations, I try to highlight that it's important to work with other people to flesh out that problem, because once you have the problem, then it becomes much easier to focus on a specific approach or solution. So I think that the problem is really an important part of getting research done. And the other thing I think is to work in a hands-on way. So really try to do something and try to evaluate a system or try to evaluate a new algorithm or that sort of thing. That help?
Yeah. I mean, yeah, definitely. So my takeaway would be, yeah, exactly, finding the right problem, a real problem, and maybe getting in touch with the field people, the practitioners.
Yeah, a real problem. That's a good addition. Yeah, thank you.
Okay. So thank you, and I can hand over back to Professor Paul.
Yeah, thank you very much to Akin and Alex for the great question, moderation, and handling. Thanks a lot for that. Let me ask two more questions that you can maybe answer quickly. So you said that the NTP traffic would be higher than the DNS traffic, which sounds quite unbelievable to me. So what kind of service would be behind that? Because even from the packet size, the DNS packet response interaction would be higher than NTP, I would expect. And so who's asking so often for the time? So which services are requesting the service?
Well, actually, it's extremely broad. So my colleague Marco, I'm not sure if he's on the line, but in this call, but he has a lot of experience in that space. But what we're seeing, for example, is that many IoT devices are also querying our NTP services.
Okay, get it. So that means they don't have a clock, and therefore they query often because the performance is so bad that they have to have it, and they luckily for you or unluckily, depending on how you pay for the traffic, they get you in, and get it. Okay, yeah, because it's really, when you said that, I thought like, okay, this is really unbelievable, but okay, this is a good explanation.
Yeah.
And the last question I would put is, SIDN Labs is quite cool in terms of what you're doing, and also with the NLnet, what services you're offering for clients and so on. Do we have similar institutions across Europe, and which ones would that be? Because I find it quite unique in your standing, and I also find it super cool that the Dutch government and your initiatives are investing in that, because I find it super important to have something a little bit more centralized in terms of pushing good goals and not only business goals. So do you
Yeah.
have sparring partners in Europe? And yeah.
Yeah, that's a good question, Mark Oliver. So first of all, I should emphasize that we're not part of the government. We're an independent organization, but we are a private organization, not for profit, but with a public role. So that's also one of the reasons why our way of working aligns so much with universities, which are public organizations with a public role, right? So it's just that our funding is different, and we're kind of we provide for our own income, so to speak. So in terms of collaborators in Europe, so there are some registries like .nl who also have a research team. So the most the well-known ones are NLnet Labs. So that's the colleagues in France. So that's Benoit Ampo, who is running the research team over there. And we have the SIDN Labs, so that's the Czech Republic. And they have actually quite a big research lab, but I think it's a combination of development and research. So we focus on research, but they also do the development part for their registry services, as far as I understood. And I think that these would be the typical partners in Europe. And we also have the colleagues in the UK. They also have a research team, although I haven't heard from them in a while. But if you look at the European perspective and you look at organizations affiliated with CCTLD registries, then I would say it's the Netherlands, France, and the Czech Republic who do the most in terms of research.
Mm-hmm. And also your point at the beginning saying like, okay, it's a non-governmental organization with public goals or positive goals. It's also quite interesting because when you look at the cybersecurity landscape with the AG Kritis in Germany, for instance, and so on, it's often the case that these are non-public bodies in the non-governmental organization structure that are the ones pushing it, which is also quite interesting just to see. I mean, I didn't look into it into detail for the moment, but maybe this is exactly the right funding structure in order to be agile enough, independent enough, and at the same time also able to acquire fundings because of the organization to go for such kind of things. Very good.
Yeah.
Perfect. Yeah. So Cristian, it was great. So it was. It went in many more directions than I expected at the beginning when we started today's edition, which is super cool. And this is also why I always love this second part, because this really enables to discuss different aspects in detail, and it perfectly complements the first part, which is much more steered by the one who is talking. Cool. Yeah. So thanks a lot.
Thank you for having me, Mark Paul. Thank you.
Yeah, you're more than welcome, and you're always also welcome again if we have slots in the future and you have interesting topics, because great pleasure. So for the series, if you did not subscribe yet on the website, on the YouTube channel, on the Facebook channel, on the LinkedIn channel, do not hesitate to do so. And as you know, we had quite a summer break, and therefore we are catching a little bit up, and we have even one more talk before the winter holidays and Christmas break. And the next talk will be on a topic which we talked about, which is cloud security. And for the next edition, which will be exactly next week, so on the 14th of December, we'll have Guillaume Neo from AWS in France, and he will be talking about securing the cloud, encryption, and data protection. His announcement and so on will be online today, so don't hesitate to share it, because the more audience we have, the better. And yeah, thanks again to you, Cristian. See you all next week, and stay safe.
Thanks.
Cher CyberCN, pôle d'excellence région Bretagne. Au revoir et à la prochaine.